and welcome to part 2 of episode 3 on the binomial distribution, probability with binomials. So in part A of this question, we looked at a car salesman that sees 20 customers on a given day, and the probability of successfully selling a car to any one of those customers is 0.05. In part C, we're being asked to consider how many cars this salesman has to sell to get a bonus. And the wording of the question is he has to sell at least C cars. So we've got our distribution. N is 20 because that's the number of customers he's going to see. P is 0.05. And we've got the probability that X is greater than C because it says at least, it says more than C. Not at least, more than C. So it's got to be more than whatever this number C is. And the probability of that happening must not exceed 0.02. So it must be less than or equal to 0.02. Okay. Now we've just got to think how we're going to calculate this. We're going to be using the binomial cumulative function, but you'll remember that that goes up to and including a value, not greater than a value. So we need to think, okay, what numbers do we want, and therefore what numbers are we going to exclude? Now, we don't actually want C. Okay, so we actually want anything that's one more than C and above. So we want the numbers that are C plus 1 up to 20, which means that we don't want 0 to C. So what that would mean is, to get the probability that X is greater than C, I would need to be doing 1 minus the probability that X is less than or equal to C, and that has to be less than or equal to 0.02. Number of ways of manipulating this now. What I'm going to do is I'm going to subtract the 1 from both sides, and then I'm going to multiply by -1, to say that the probability of X being less than or equal to C has to be greater than or equal to 0.98, and then I need to work out what this C number actually is. It's a good idea at this stage to think about the expectation of what's going to happen, my expected value. And the expected value, well, if I see 20 people and my probability of selling the car to them is 0.05, then on a given day, my expectation is actually 1. That's doing the number of sales times by the probability. Expectation, something you would have met in GCSE. Same principle. And so if we're expecting to sell 1 car, then actually to get to this 0.98, we're probably not actually going to have to go that high. So what we do is we go into the cumulative binomial list function, and we put in our values of X. So I've just worked out the values for X is 1, 2 and 3, and I've got the probability of X being less than or equal to that value. Now for 1, it's 0.7358. If you remember, we used that in part A. For 2, it's 0.9245. And for 3, it's 0.9841. Now, greater than or equal to 0.98. The first value that goes past 0.98 is this one here, which means that C is 3, because that's the number of successes that I have to get up to and including for the probability of that to be greater than or equal to 0.98. However, that is not my answer, because the question very clearly says how many cars does the salesman have to sell to get a bonus, and they have to sell more than C. So if they've got to sell more than 3 cars to get a bonus, the salesman must actually have to sell 4. So the salesman has to sell 4 cars to get a bonus, which when you consider he's seeing 20 customers in a day, 1/5 of the customers he has to make a successful sale to, seems unlikely. Thank you.